Okay. Good morning, students. This is Suraj Patel and welcome to Math Chef YouTube channel. Right. So today is the function, right? Invertible function. Okay. Already have studied the function, all functions. Invertible functions, inversible functions, or inverse function. Okay. Various names. Let's take the one example. Okay, let's see. Just writing. Okay, f is a function from a to b, and a is some point a, b, c, right? And b are some point e, f, z, right? In order pair, how will write? See, f is equal to, right, is a function, right? Is a function such that, okay, f is a function such that xy, okay, right, xy where x belongs to a and y belongs to b, right? So this we are writing as, what is, a e ordered pair, right? A e and b f and c g. Just consider a is the function from a to b. Okay, a is abc and b is efg. Efg. Right? Just only what the order pair is a, b, f, c, g. Right? C is another function. Okay, g another function. G. Right? G is a function from B to A. B to A. What is the B here? So G is set of, okay, is equal to set of yx such that x belongs to A and y belongs to B. So how to write G? G. Okay. What is the E A F B and G C, right? Just focus on the types of element, okay? Pattern of elements in the F and G. Just see the pattern, okay? Pattern A E E A, B F F B, C G G C, right? So it seems to be na. This is the inverse. So A C C A inverse and FB, BF are inverse and CG, GC are inverse elements, na? Inverse elements. Okay, that's so. Let's define the inversible. Okay, then C, FB and ABC, BC, ABF, GC is the function like that, right? If the inversing means after the making the inverse element, if you take the return element, inverse element, if we get the same elements in reverse order, reversing it. Okay. If we reverse the ordered pair, if we reverse the ordered pair, again we will get the another function that is called invertible function or inverse function. If they reverse the order of the ordered pairs, elements of the function in ordered pairs, again we get in the another function. Okay. That is called a reversible function, means invertible function. If you reverse the element, right? So, what are the main conditions do the relation, okay, the function become inversible? First, just check, okay, sir. Okay, domain, okay, sir. Domain is equal to range, right? So, domain becomes a range, first of all. How when? So, this is domain is 1 1 for every element is used getting the another element, okay, and okay sir, and range is onto the function with respect to domain, it is 1 1 and range is onto means only the, so okay sir, B is a, okay, a function of A elements. B is the, what do you write? What is the onto? You write y is equal to f of x, right? Definition of onto. Okay, if the B set is only the elements corresponding to the elements of A, right? This is the what is the condition? Function should be first the function should be invertible. Another one, what is inverse function? First, f must be 1 1 and on 2. Very simple. F must be 1 1 and on 2. Right? Let's see the definition. Okay. How it is? This is the function x to y. X to y. It's not visible, I think so. Right? Function from x to y. Okay, this is the x, this is the y, this is the domain. Okay, right? This is the function of x to y, and this is the circle. And again, I am making this side. See the symbol function. This is f of inverse. Okay, and this is the reversible. Okay, sir. This g is the inverse of x here. G is inverse of f divided by f of inverse. So, okay, so g is equal to f of inverse, f to the power minus 1. Right? Okay. This is the element. This is the y is equal to f of x, and here x is equal to y of f inverse of x, f inverse of y. Right? Here, okay, sir, some concept again I can tell the by properties. By seeing the properties, I can explain. What the function is here? Definition. Okay, definition. Let's see the definition. Okay. Okay, sir. Again, to give the exact now, I'm using the books. The definition is let f is a function from x to y, right? Be 1 1 onto function, be 1 1 and onto function, 1 1 and onto function, and if f of x, okay, sir, f of x is equal to y, where x belongs to capital X and y belongs to capital Y, then f inverse defined as function from y to x defined by f of inverse y. Okay, I told you na, g is equal to f of inverse y is equal to x is called right an inverse function of x, an inverse function of x, inverse function of f. Okay. I'll explain the definition again. The function f of x is a function from x to y. Be 1 1 and onto. 1 1 means every one input there should be a one output. Onto means Okay, the number of, okay, so that should be a range only. The codomain is equal to range on 2 means y is equal to f of x. Codomain must be range means the range should not be a subset of the codomain. Okay, this is not available. RF is codomain. This is not possible. Okay, so our range should be codomain. Okay, this is the condition. Range should be codomain. That is onto na condition, right? Onto f of, if f is a function from 1 to, very important. This is the important concept. And onto, and if f of x is equal to y means these elements is equal to y, where x belongs to x and y belongs to y, then f inverse written as f to the power minus 1 from y to x defined by f of inverse of y is equal to x is called an inverse function or invertible function or another one inverse function. Okay, inversible function. Okay, some properties are there. Okay, some properties is the a function from y to x, right? F of inverse. Okay, some properties are there. Domain of, okay sir, one and one. The first one is, okay, domain of f inverse is equal to, okay sir, range of f. Here domain of f inverse, this is the function from here, this becomes domain. Okay, domain range, this is domain, this is called range with respect to f inverse, right? Domain of f inverse is equal to range of f. Second one is, okay, domain of f. Okay, domain of f becomes, right, range of f inverse. Can I write range of f inverse? The another point is there. Okay, and the very important here. Okay sir, f of inverse of y is equal to x exist. Okay, exist if and only if y is equal to f of x. Okay sir, x belongs to capital X and y belongs to capital Y. This is important. F of inverse y is equal to x exists only if and only if this is defined, then this can be defined. This is not defined, then this cannot be defined. F inverse cannot be defined, right? Go to y, right? F of x is equal to y. Let's see the identity function. Okay, some properties of the universal functions, they give one different way. Okay, so let's see the some properties of the function. So next concept is, okay, let's see the identity property, how it behaves here. So let's take the function, okay, from x to y, so that y is equal to f of x, right? Such that x belongs to capital X and y belongs to capital Y. So g is a function from y to x, such that x is equal to y of, okay, x is equal to function of y, such that x belongs to x and y belongs to capital Y. Don't get confused. Okay sir, this is the very important here. Let's see composition of the functions. Okay, how is the composition of function? How to write g? Okay sir, g(o) of f of x, g(o) of x. how you are writing this one as, okay, this is the function, okay, this is the function from x to x definition, right? Function from x to x. See, f is a to b and g is a function b to c. How we will write? G composition of x is a function from a to c, right? Here from x to x. Let's see, g of f x is equal to g of f of x, right? This is, what is f of x here? F of x is equal to y. Okay, this is g of y, right? So what is about g of y? G of y is x. Very important. Again, you can see f is a f of composition of g is a function from y to y. So how to write this one as f g of y? This is the x. That's why I am taking x. This is the y. Taking y. So this is f bracket of g of y. G of y. This is f. What is g of y is x. Okay. And what is the x? That one. F of okay. F of x is y. See the difference. Okay. What I am getting is this. F of g and f of g I am getting x and f of g is getting y and g of x I am getting x. Okay, can write this one as c f of g as ia and g of o as ix. Identity functions. Identity functions. Okay, and functions. Okay, just replace the term g and f. Okay, so f of f inverse, okay, is equal to ia I y and f inverse of f is equal to I x. Okay, composition function, the identity function is itself tells the story. F inverse of, okay, you should be careful again here, right? Okay, the function is function from this is the identity function, right? This implies that ix and this function what tells iy, right? First one is f of inverse. Yes, right, sir. The identity function itself is a story tells. Okay, let's see. G of f is equal to ix and f of g is equal to iy. F of g, the y. Let's see the property. What are telling here? Okay, sir. If you taken the function g to f, will get the ix, and f to f will get the f to g will get y to y, right? Very important. Okay, sir. See here the confusion part is, okay. F of g is a function from, okay, x to y to, okay, y to x. This is the first value. The first is x to x. That's the first. Okay, g is f is first. Again, if okay, is this g of x? G of a, right? And f of g is a function defined as y to x defined to x to y. x to y. So this becomes y to y. Very important. Okay. Let's see some properties. Again, this may be a confusing part, maybe may not be. See, clarification very important. See, when you get clarification, only by multiple readings. Okay, repetition is the king of study, right? Repetition is king of learning, not okay. Repetition is king of learning. King of learning, right? Think about it once. No one will get the clarity for one time. Whoever it may be. One reading it one time. No, you only have the multiple IQs questions. That's not possible. Okay. Next, some properties of the inversible functions. Let's study some properties of the inversible functions. Let's see some properties. Okay. First one is inverse of a bijective function is unique. Okay, sir. Inverse of a bijective. Bijective means 1 1 and 2. Bijective function is unique. Unique means only yes, only one way is possible. So if it's not unique, then it is not a bijective. Not bijective, then it's not a inversible function. Second one is the inverse of bijective function is also okay, sir. Inverse of a bijective function f is also bijective, and f of inverse is f. Okay, the inverse of a bijective function, right? Bijective function is also bijective. And f inverse of inverse is equal to f. Inverse of bijective function is such that if you want to show that the question is like that, show the inverse of a bijective function is also bijective, and then you have to show this one. Inverse bijective function, right? Then if okay, sir. Next one is okay. If a function is defined from A to B, right, is bijective. Okay, this is also important also for MCQ also. In theoretical part, they given like that. Okay, if a function A to B is bijective, then you show na f inverse of f is equal to I A. And first one, f of f inverse is equal to I B. Just I showed here. Okay, I A. F is a function from A to B, and G is the function from B to A. How will I write here? This is also f of inverse. I am writing G of f is equal to A to A, right? G, what is G? F inverse of f is equal to A to A. This means was IA, right? And f of G f of g is function from b to b. What is f? G. F of f inverse is equal to, what is b to b? B to b is ib. Identity function. What are identity functions? The identity function definition is IA is function from a to a only. Means you are getting same values with same elements. Right? Next property is, okay, fourth one, if f is a function a to b, right? If fourth one, if f is function from a to b, and g is a function from b to c, are both bijective, okay, are both bijective, then GOF small o f is equal to a to c, and FOG is also bijective, okay, is also bijective, and GOF inverse of inverse, right, is equal to f inverse function composition G inverse. See sir, okay, GOF, the inverse of this complex function, okay, not this one, sorry. Inverse of composition function GOF is f inverse composition of G inverse. Okay sir. Fifth one, okay, if a is equal to, f is equal to function from a to a, and g is a function from a to a, and a is a non-empty set. I write this one as, we have two functions such that GOF is equal to a, GOF is equal to IA, and okay, this is equal to FOG, if it is like that. F and G are both bijective, and G is, okay sir, then okay sir, this is the then F and G are both bijective, and G is the inverse function of F, right? G is the inverse function of F. I will explain the things once again. See, this is the theory is like bare X in law. What the bare X? Bare X tells as it is. If you want to study the bare law of the Constitution, that is, you have to go 1950, before 1950, not right now, the traditional books, okay? Market now, which books available market, that is not, that applied, okay? Edited books. Bare law, the bare study means BRE, as it is theory. So, means na, because one, when they are writing, they are giving definitions in some different ways, na, bold numbers, folded number, different folds, na. It has some, okay, peculiar characteristics, okay. In teaching in easiest way, we can convince in easiest way, but actually bare act, bare law, bare theorem, okay, bare words also very important. So, inverse of a bijective function is unique, right? Inverse of a bijective function is unique. Okay, what is bijective? 1, 1 and 2. See, wherever 1, 1 is there, now you have to get in one input for one output, different input, different output. Okay, that is calm one. Only one will get, no? Right. Then, if it is not unique, it is not a bijective, right? Not bijective, not Inverse. The inverse of a bijective function is also bijective, and that is inverse of a bijective function. This is also bijective, means f. If f is equal to a to b is bijective, then this one is the identity function. The function from a to a is called ia, and function from b to b called ib. Okay, first function. Right? If a is the function a to b and g is the b to c are both bijective, then g composition of f, right? F composition of g or g composition of f, you can read, is a to c is also bijective, and g of inverse is equal to f inverse composition of g inverse. And f is the function from a to a. This is the double dot, right? A to a, g is a to a, and a is non-empty set, right? So g of is equal to ia is equal to f of g. This is called bijective, and g is the f of inverse of f. Okay. And we will solve some questions based on this one. Okay. Let's solve the questions. Okay, let's see the examples. First one, state with results whether the following functions have inverse. Find if inverses exist. They have given some inverse functions. I have to state whether the function is invertible or not. I have to find the inverse if it is exist. First one is f is a function, right? Defined from 1, 2, 3, 4 to, right, 10. Okay, and f is given. Okay, f is equal to order base 110, right, 210, right, 310, and 410, right? Whether this is the function is invertible or not. All function are okay. All the elements of f are mapping to the one single element. So what the condition is? To function to be invertible, f should be 1 1 and f should be onto. 1 1 means for each element you should get the different element, different input, different output, different input, different output. What about this one tells? This is the same element you are getting, okay? Single. This is the not, this is the manual function, not, okay? So here f is not 1 1 because it is manual function, and f is not onto, right? Onto also is there, no? Not onto. Okay, onto is different. Depends on the onto. Okay, we are getting this f is onto. Okay, we can say f is onto, but it's not 1 1, na? It's completely not inversible. Okay, f is onto even though because of f is not 1 1, it's not invertible. Therefore, f is not 1 1. Therefore, f is not invertible. Therefore, f of inverse does not exist. If they given 2 marks, na, we have to write these all things. If they give 1 marks, just write f is not 1 1. Therefore, f is not invertible. If 2 marks, just something else. Next one is f is a function from 5 6 7 2 1 2 3 4, right? Second one is f is a function from defined 5 6 7 to 1 2 3 4. 1, 2, 3, 4. Right? And what they given is f is 5, 6, and they given in ordered pair. Okay, like that. This is 6 na ordered pair. 5, 4, 6, 3, and 7, 2. Right? And to show whether is the invertible or not. Let's see. F is 1, 1. Yes, F is 1, 1. Therefore, F is 1, 1, 1 because domain, okay, domain of F is 5, 6, 7. Okay. What about onto? Okay. And range of F. Range of F is what? Range of F is 4, 3, 2. Okay, you can write also. 2, 3, 4 is a subset of codomain. Codomain. Therefore, the proper solution is the not onto. Into function. Therefore, RF is okay. F is not onto function. Onto function. Therefore, F is not invertible or invertible. Why it should be onto means see. Only 2, 3, 4, 1 is left. When you making the reverse function, inverse function, what about 1? So other function, domain element should have at least one image. At least. Okay, at most. Okay, only one element. Okay, it could not have more than one elements. At most, domain element at most have one image. If not any image, that is not a function. Therefore, second is also as right. F is not onto. Let's see. Third one. Sorry for the inconvenience. Next one is F is okay. Same question. F is defined from 2, 3, 4, 5 to 7, 9, 11. Okay, 7, 9, 11, and 13. And F is in ordered pair 2, 7, 3, 11, 4, 13, and 5, 9. 5, 9. Let's check the inverse of this function. What is F is the function from 2, 3, 4, 5 to the 7, 9, 11, 3. 7, 9, 11, 3. So, okay. See, domain of F is, okay, sir. One thing I can show is domain of F is equal to range of FC. Nowhere they write this one, but still I am writing. Okay. Right? Oh, the condition is if it is a reversible function, so one condition I can do. Okay, right. Then F is 1, 1. Yes, you are using the all elements. F is 1, we are getting the corresponding elements. Okay, therefore, and f is 1 1 1 also. What about and 2? Where is the all elements na? Okay, domain of f is okay. Domain of f is better write 2 3 4 5 and range of f is equal to 7 9 11 13 is equal to codomain. Range becomes codomain, right? And f is onto. F is onto. Therefore, f of inverse is f is invertible. Invertible, and f of inverse is exist. And f of inverse is already inverse. Right? How to the inverse is okay. F inverse okay is a function from C. Writing 7 9 11 13 2 what is done 2 3 4 5. This is okay, but they are not corresponding elements also, but have to write in this important. It's order very important, right? Order very important. This is like A B B A. So ordered pair. Therefore, f of v is equal to right. Or the reverse the elements. 7 2 11 3 okay 13 4 and 9 5. Okay. This is the very simple and easiest question in this one. Next questions are very complex. Okay, I think so. Yes sir, time is up. So I can do only one question. I can solve only one question in this time. Okay, only 10 minutes I have. So what I will do, I will conclude here. So next I will come with the special class only for this person. This invertible functions. These functions, because you will get the complete grip and pattern of the some different questions also. Okay. What done today is invertible function or inversible function or inverse function. So what the main condition is, first one, function should be 1 1 domain to range and onto. Range should be equal to codomain. First condition, right? And then it is invertible, right? And the other property is the domain of the function becomes a range of the inverse function. Okay, the domain of the function becomes a range of the inverse function. And next one, the range of the function becomes domain of the inverse function. Range of the function becomes domain of the inverse function, right? If the function from same set, the function one from same set is identity element, right? Will surface and okay, this is the some topics. Okay, identity elements and bijective also have. And if f is bijective and f of inverse also bijective, and composition, you know, composition exists and gives the if the function is mapping from same set, the composition becomes an element. Okay, if the function mapping in the same set, mapping itself in the same set, the composition function becomes composition of the function and inverse function becomes identity function. Identity function IA, IB, these are that things. Okay, anyway, let me to conclude the class. So next class. Okay, only we have one more concept, binary operations. I think so. Then it comes to the trigonometric, inverse trigonometric function. Again the complex. So difficulty. Okay, typically class 12 syllabus is quite complicated. Then the class 11, class 12 like the basics and difficult apply like that. Okay. So thank you very much watching. So please comment in the comment box regarding my quality and quantity and other one quality and quantity. You can add another word. The comment box. Let me to grow up here. And okay, we will see in the next class. Thanks for watching and bye.